I'm gonna give you a really fast breakdown. So for those of you guys remember things, there is a something called polar coordinates. Uh, polar coordinate is wait, let's not plug in. Right. Oh, great. All right, so those of you guys never seen polar coordinates. It's really easy. So this is why it's not writing. Okay, this is a Cartesian coordinates, or also known as a rectangular coordinates. So Cartesian, I have no idea how to spell. I'm gonna make shit up. Cartesian coordinate. I spell it right? Oh. Okay. So, or also known as a rectangular coordinate. So, in order for you convert from polar coordinate to rectangular coordinates, I need you guys put your phone away. So how do I convert to polar coordinate? Does anybody remember how to convert to polar coordinate?
Isn't it r cosine theta and r sine theta?
What is equal to r cosine theta? Yeah. X equal to r cosine theta and y equal to r sine theta. And there is something called this is how you convert. Actually, this is how you convert from polar to rectangular. So this is polar to rectangular. And the other one is x squared plus y squared equal to r squared, and tangent theta is equal to y over x. And you say that's an extra memorization. Does not. If you look at this just means cosine theta is equal to x over r, which is adjacent over hypotenuse, which is something that we already know. It's not something that you have to memorize. So basically, x equal to r cosine theta, y equal to r sine theta. X squared plus y squared equal to r squared. Tangent theta equal to y over x. This one is from rectangular to polar. Is that okay? Now, the polar coordinate is going to represent is always in this way. It's going to be r and theta. R does not call it radius, but it acts like a radius.
Basically, distance
Away from origin. It's distance away from origin. So you say, okay, well, how do I convert one to the other? So I'll show you how to convert from one to the other, and I'll show you how to convert back. Okay, so let's start with the rectangular. 2 and negative 2. The best way is to draw it out. 1, 2, and 1, 2. This is the point, right? And we say, hey, how do I convert this to a polar coordinates? All you're going to do is look at this. You say, oh, okay, well, I'm going to use the equation on the right-hand side because I can do 2 squared plus negative 2 squared is equal to r squared. So that's be 4 plus 4 equal to r squared. R squared is equal to 8. R equal to plus minus square root 8, which is plus minus 2 root 2. And tangent data, that's easy. Tangent data is going to be y over x will be -2 over 2. So tangent x equal to -1 over 1, which is -1. When's the tangent x equal to -1? Tangent of data. What's tangent data equal to -1? Data is equal to what?
Negative 3 pi over 4.
Not pi over 4 because I give you.
Negatives continuing the same.
Yeah, but we're not asking inverse.
Uh,
We're not asking 10 inverse of -1. 10 inverse of -1 will be negative pi over 4. There's two answers, but which answer is better? Look at a coordinate. Look at which quadrant is that. 7 pi over 4. Yeah, so 7 pi over 4 is the best. Or 3 pi over 4. This is the best coordinate. So then you're going to have a 2 square root 2 and 7 pi over 4. And that's how you convert from the things. And you're going to be like, oh, okay, well, what does that mean? That also means this. Why do I have plus minus? Because you can also have to represent, there's infinite amount of way to represent the same coordinate. The same coordinate could be -2 root 2 and 3 pi over 4. That means go into the opposite direction. So if you go to 3 pi over 4 first, so I always start with the angle. When I look at the coordinate, I start with 7 pi over 4 and I go to 2 square root 2. Or I go to 3 pi over 4, I go -2 square root 2. Now, you guys probably like look at me like I'm crazy.
I mean, I understand it. You're basically going backwards from
Exactly.
that angle.
But I will show you coordinate first. So first of all, you have to understand how to use decimals because you can use decimals. If you click here, you're gonna see a polar axis right here. So if you click, you can try it. This is a regular grid. This is a rectangular grid. This is a polar grid. Do you see that? And polar grid that you say, okay, well, I want to 2, -2, I think, and that is the point. This is the point that we're trying to represent. Then you say, oh, well, what's that mean? Well, this means I'm going to do r equal to this, r equal to 2 root 2. So that means 2 root 2. That means 2 root 2 is about 2.8-ish. It will be 2.8 radius away from the pole, which is the origin. Origin to the thing is gonna be that. And you say, okay, well, I say, hey, how do I convert this to rectangular polar coordinate? Well, the polar coordinate is basically 2 square root 2, and it's gonna be 7 pi over 4. So you think about it. From here to here is 2 root 2. Is that okay? That's 2 unit times square root 2. Right? And this direction is what? 7 pi over 4. 7 pi over 4. Is that okay? So can represent the same coordinate as this. Let me finish. Or you can do the other way, which is I can go with the blue part right here at 3 pi over 4, but go opposite direction. Which is opposite direction is still going the red direction way because it's a negative. So what I'm trying to say is there was an infinite amount of way to represent the same coordinates. You can say infinite amount of way, you can 2 square root 2, and you can say, well, if it's a wheel, if a circle, I can go with, I don't know, 15 pi over 4. Does that make sense? Because 15 pi over 4 is literally on the exact same angle as before and have positive 2 root 2. And now here, I can say -2 root 2, comma. I can say, well, that could be 3 pi over 4 plus 2 pi, which is 11 pi over 4. All this represents same exact coordinate. All this represents same exact coordinate. And so way to think about it, you want to represent the coordinate, you can be r theta plus 2m pi. Or negative r theta plus m pi. Actually, hold on a second. Not m pi, but it's 2m. 2m plus 1. So this is going to be a way to represent infinite amount of same coordinate. Okay, so how many of you guys don't understand? Raise your hand. Yes.
I just don't get the like the first polar coordinate. That makes sense. But then can you just go over like why if you flip the negative?
Yeah. So let's look at here. I can go to 7 pi over 4. I can go to 7 pi over 4. The reason why I can go to 7 pi over 4, if I can go 7 pi over 4, it's going to be exactly the same quadrants, fourth quadrant, right? But I can also go across in the fourth quadrant. I can go to the third quadrant, or second quadrant, at 3 pi over 4, and I go opposite r. So basically flip that positive r to the negative r.
Is it because we had two r's when we did the like x squared plus y squared?
Yeah, the r can be negative. It still represents same coordinates. So basically that's just going to be applied to that. You can actually think of that way. So that way you know what is a polar axis. You can represent multiple coordinate with this idea. So this idea, I can just add 2m pi. Or I can have this plus 2m plus 1 pi. Why is 2m plus 1 pi? Because I could have plus pi is 180-degree rotation. So it's going to go opposite direction and give you a negative r. So you can go it that way too. But you don't have to know all that, but just in a pre-calc, the teacher is supposed to tell you, says, okay, there's an infinite amount of way to represent same coordinate. So not just 2 comma negative 2 anymore. It could be 2 square root 2 7 pi over 4 or negative 2 square root 2 3 pi over 4. Got it? And if you say, hey, I don't know if that's true. Well, we know this is r cosine theta and r sine theta. This is a rectangular format, right? If I just do that, it'll be 2 root 2 times cosine of 7 pi over 4. What's cosine of 7 pi over 4? And 2 root 2 and sine of 7 pi over 4. What am I going to get? 2 root 2 and this one square root 2 over 2, right? Is that okay? So 2 cancel out and this becomes 2, right? And this 2 root 2, that's equal to square root 2 over 2, negative. So 2 cancel out, that's equal to negative 2. It becomes a rectangular format. We just convert it back. If you don't believe me, you can use the same thing to convert back. Let's use the same thing. I'm using blue part to represent that. We're going to say negative 2 root 2. Cosine of 3 pi over 4. Is that okay? And negative 2 root 2 times sine of 3 pi over 4. Is that okay? So that's going to be negative root 2 times negative square root 2 over 2. And that becomes positive. Negative 2 root 2 times square root 2 over 2. That becomes negative. So 2 cancel out, that's 2. And this one, 2 cancel out, that's going to be negative 2. It's still giving me the same coordinate, same representation for both. So that's how you feel like. Yeah, go back. It's not just r times sine theta and r times cosine theta. It's kind of like same thing what you do with physics, right? If you have a projectile, right? There is a x and there's a y. It's kind of like something like this. It's gonna be r sine theta to represent the y perspective. R cosine theta is represent the x perspective. Do you guys remember that in physics?
Yeah. It's like conversion.
Like Ollie not Ollie, the Greenwald teach you, or the video teach you. Video teach you. The video teach you. Okay, so is that okay? So that just means a representation of that. So your homework is gonna have some conversion. You have to convert back and forth. But how do you convert rectangular to polar coordinate? We already know how to do that. Polar to rectangular. Do you need a practice or no? It should be pretty easy, right? Okay, we're gonna move on.
You find the derivative of a point.
We haven't get that today. We get to all the pre-calc stuff today first. So tomorrow, this is pre-calc.
Yeah, we just.
You did this in pre-calc.
Oh yeah.
Yeah. So some people did not do it in pre-calc, so that's why I'm going over it. So x plus y equal to 5. How do I represent this in terms of polar equation rather than rectangular equation? So there is a rectangular coordinate and polar coordinate, but there is also a rectangular equation versus polar equation. And the thing is actually pretty easy. X is equal to what? In terms of r, x is equal to what? R cosine theta, right? Plus r sine theta. And that's equal to 5. Factor out r. So r is equal to 5 over cosine theta plus sine theta. And this is a polar way to represent x plus y equal to 4. Well, why does that matter? Because you have to see that, you know, x plus y equal to 5, right? That's the slope of negative x, y-intercept at 5. Or you can say r equal to what? 5 over what? 5 over what? Cosine theta plus sine theta. Is that okay? It represents same line, but it's a weird equation that you never seen before. It's in terms of r, but represents exact same thing. Am I going too fast? Should be pretty easy. Now you try one. But you remember, you had to solve for r, okay? You had to solve for r. So this one's kind of hard. This one's circle. Now, normally I would spend 2 days on pre-calc, but today we're going to spend half day on just talking about pre-calc stuff. You want to solve for r here? This one is kind of difficult. Kind of. Let's see if you can do it. I will tell you, one of the r is equal to 0, though. And that's not the right one. That's extraneous solutions. Or extraneous equation, I guess, in this one. expand them. Do you get it, Nathan?
Yeah.
Where'd you get it?
2 cosine theta.
Okay. R cosine theta minus 1 square is equal to R sine theta square is equal to 1. R square cosine square theta minus 2R cosine theta, is that okay? Plus 1 minus plus R square sine square theta is equal to 1. Can the 1 cancel out? Can this 2 combine together is equal to R squared times cosine square of theta plus sine square theta minus 2R cosine theta equal to 0. This is a 1. You can factor our R minus 2 cosine theta, and R equal to 0, R equal to 2 cosine theta. So this is the rectangular way to represent this. This is polar way to represent that rectangular equation.
You're solving to make.
I'm isolating R. Is that okay? Am I going too fast? Should be very straightforward. So rectangular to polar is not too bad. Ten or you kill puppy.
I was just confused. I thought maybe like
Yeah, exactly.
Okay, so that's just a brief understanding how to convert from one equation to the other equation, but how do you convert polar to rectangular form? So let's say R equal to 5. This is an easy one. R equal to 5, and you say, wait, okay, I don't know how to do this because, but go back and look at the equation. They don't have R. They have what? Go back, look at this equation. They don't have R.
Should now be back A1.
This is rectangular to polar, and we did that. Oh, that's a polar coordinate, but the other way says R equal to 5. Then you say, wait, R equal to X over cosine theta, R equal to Y sine theta, but there's R squared here, right? So can I just square both sides? And that becomes X squared plus Y squared. Or actually R squared equal to 25. And that's X squared plus Y squared equal to 25. So you just convert from R equal to 5 to a circle equation. R equal to 5. If you type in R equal to 5, it's going to give you exactly like that. Just look at it. R equal to 5 if a circle radius of 5. It's X squared plus Y squared equal to 25. And just convert from one to the other one. So I would say polar equation is a very cool way to represent a function.
So polar equations basically would allow you to make any function. Like you could basically just do any function in it.
I think most of the function will be fine, but there was some function, maybe I don't know, because I hate to say you for definite, because there's a lot of math I don't know, so I won't be able to tell you like is any function represent. When I first started learning it, when I was in high school, I never think about polar function can represent lines, but it can. Obviously, we got phi over sine theta plus cosine theta is represent lines. Okay, so how do I represent this one? Well, pi over 4. And you're like, wait, this is data, that's not r. Well, that's okay. Which one is involved with data?
Well, that just means that it's
Tangent. So what you can do is you can tangent both sides. And tangent to both sides is this is equal to 1. But what's tangent?
tangent is y, right?
So y equal to x. Remember, y equal to x is a 45 degrees, right? And it's a pi over 4. This theta is equal to pi over 4 because y equal to x is a 45-degree lines.
Oh, that's actually crazy.
Dude, that's crazy, Mr. Gray.
Pretty interesting, right? Now this one you need to think about it a bit. This one's also easy, but it's not hard. What is this representing? Some people can figure out. I think half of you guys can figure out. It's really easy, one step. One more step, Khrushchev. One more step. One more step. You got this. There you go. Yeah, so Rajan Khrushchev is right. So 3 over sine theta. Right? And you can multiply both sides by sine theta. It's going to be r sine theta is equal to 3. And r sine theta is what? It's a y equal to 3. It's a horizontal line. Or equal to -6 cosine theta. This one's hard. This one's hard. You gotta hit 2 birds, 1 stone. Yeah. You gotta hit 2 birds, 1 stone. How do you hit 2 birds, 1 stone? How do you hit 2 birds, 1 stone? Wait, what did you say, Khrushchev? Pick up a rock and throw again? I thought you're gonna pick up throw one and then pick up a rock and throw.
Hear me out. Where? What if we square both sides? Oh, R squared is negative x squared plus 1. I'm cooking.
You only had one. You only had one bird. Roger's gonna be like DI method. Let me do DI.
Oh, it's negative.
Okay. Anybody know how to hit two bird one stone? I will tell you not square both sides because on the right side you're gonna get 36 cosine square of theta. But there's a problem there. What do? Come on, think outside the box. Wait, Raj, what did you try? No, don't square root both sides. All right, so shh. You guys cannot think outside the box?
Nope. Is equal to x squared plus y squared.
X squared plus r squared equals to negative 6r cosine.
No way. No way. You're so good.
R equals x squared plus y squared equals negative.
Because this is the x, right? You had two bird one stone. Instead of square both sides, you got r squared on one side, but you don't have an x on the other side. But could you just multiply r on both sides? Sophia, you thought of that?
We did it.
Okay, teamwork.
That's not a lie.
Teamwork. All right, so now this is a not very good representation. So what we can do is we can add 6x on both sides and y squared. I mean, sorry, that's gonna be y squared equal to 0. So we can complete a square. 6 divided by 2 square is equal to 3 squared is equal to 9. So plus 9, so it'll be x plus 3 squared plus y squared is equal to 9. And that becomes a circle equation that go back to before. How much time I have?
Like 10 minutes.
No, you got like 2 minutes.
What?
How are you able to tell when you're supposed to do a circle and when you're not supposed to do a circle?
No, I wish that was fine.
If you have r squared, that's a circle. All right. Now we're gonna work on Desmos for a little bit because that way you guys know how to use Desmo and calculator. So, and you gotta learn, get your calculator out, and let's learn how to work through how to graph it. So let's talk about. I don't know how to pronounce it. I thought it was lemon kong, but somebody says lemon song, but I don't know. Which way is it? Is it lemon song? Are you sure? It's a French.
It sounds French.
It's called Limacon. No idea what is that. So today we're just gonna talk about decimals. We're not gonna talk about things, but I'm gonna show you something, which is the. We're gonna talk about rose paddle. We're gonna talk about rose paddle first.
If it's like some of them, it depends on like how many pedals. It depends on like what figure it is. I think sine is how many pedals.
Okay, so the way you think about it, the odd one is always gonna be represent exactly same amount of paddle. So if you the odd one, you might want to write down this because you just type in 3. Guess what? 3 paddle. But it's kind of deceiving. I'm gonna tell you why that's kind of deceiving in a second. But what happened if you did 4? You're gonna get 8. So all the even, you're gonna get double. All the odd, you're gonna be the same. So imagine 5. What's gonna be 5? 5 pedals. Wow, Anderson. That's what happened. You play too much League of Legends.
Wow, he just used
Oh, that's Alvin. You know, I explained to my son. I says, look, all these people, like, you know, in China, there was like gaming team, right? And they said they went to research on those people. He said those are all top students. I'm serious. You know how in China there's Gaokao, right? Gaokao is like hard, 100 times harder than SAT, 1,000 times harder than SAT, and the full score is 700 point. And all those people that on the gaming team score 650. That means you can't be like. It's that test is harder than 1,000 times harder than SAT because they have 8 different subjects, and even math I can barely pass. I will tell you the truth. Even math is really hard. I can barely pass. It's called Gaokao. Yeah, Gaokao. If you look at a Gaokao question, they are hard. They are really difficult. And they research on those people are playing on the team. They realize what happened. They say, hey, how you guys get so good? He's like, yeah, I just finished all the homework at school. I never left any homework, so I got all the gaming time at home. And that's why they score really high, because they were so smart. They finished all the stuff at school already, and at home they just gaming all day. Huh? Yeah, and I told my son about clicking speed. I said I have one kid that has super fast clicking speed. Wait, how fast you can click on the clock? Like on like a stopwatch. 0.07? Have you ever tried it before? Your clicking speed is slow? Or keyboard? I think keyboard is fast. Okay, so anyway, every odd pedal is gonna be the odd pedal is gonna be exactly same amount. If it's even, it's gonna be double. Now there's a reason why though. Pay attention to the reason. Why is a 5 pedal is hard? But if I look it back here, and then you will see why they are like this. So we're gonna say that is C. We're gonna say that's C and add a slider for C. C is gonna be between 0 to 2 pi. Okay, so this is how I set up. And if you see C here, that if I start from 0, this is how they draw. So I must slow down. But do you see that it's continuous? But why is it continuous? They repeat the same graph twice. They repeat the same graph twice. Because after 3.14 here, it should finish the whole graph. Right? And they will continue that line along to the next one. They will keep on drawing and you're not able to tell. But if it's 4 data, you're gonna see here. it's a 4 data, then they're just gonna keep on tracing after pi. So after pi, pay attention, after 3.14, they still tracing. So that's why you have the other even one has odd, but the other even one has other even one is double. Other odd one is gonna be same exact amount because they repeat the same pattern twice. For the odd one, they repeat the same pattern twice. Does that make sense? Or no?
Yes.
But this is all the way you have 8 paddle. But if you look at it, you look at a 3, right? You look at the 3. Look at between 0 to 3.14. So go back and go back, and they go to the same track. Because if I start with pi, you're gonna see exact same thing.
Is it the same thing for cosine?
Yeah.
Oh, they already show because they already showed the first part. So for cosine, let's check cosine.
The animation button.
It's the same thing. They repeat the same pattern twice. So they still have 6 paddle, but they just repeat the 3 paddle at the same as before. Does that make sense? Now, how do I shade them? I can actually show you how to shade them. You can look at this, and this is what you need to know for tomorrow, okay? And you cannot do that with, I don't think you can do that with TI, but I don't know if you can. Try it. But you can do less than. Wait, let's show you what less than then. Where's less than that? Where's less than? Oh, there's.
Whoa.
That we're gonna say 0. And see how they calculate area, because we're gonna have to deal with areas tomorrow. This is how you calculate area. From the center going like this. From the center, from the origin, they go like this.
Did you see that? Did you just see what Aiden did?
Show me tomorrow.